Really excited to have all of you here, as Dr. Yao said, even on a Friday evening. So I just want to begin tonight with a few brief introductions and a little bit of background. So I am Dr. Kelly Watson, and I know that I know most of you, but I'm the Associate Director of the Division of Natural Areas at Eastern Kentucky University and the Associate Professor of Geosciences, and I'm also overseeing SSLI. And to give you a little bit of background about the Science for Sustainable Living initiative, it's a cooperation between Eastern Kentucky University's College of Science, the Division of Natural Areas, and Green Crew, which is the student environmental group at EKU. And our mission is to promote environmental sustainability, specifically through science and STEM-based education and outreach. And that includes working with the EKU community as well as the public and providing opportunities for student interns to take leadership roles in environmental sustainability as well. And so this is actually the first in a series of workshops that we will be featuring, along with several additional events that are in the works. And we definitely want to thank our generous sponsor, Novelis. And Novelis is actually the world's largest recycler of aluminum, and they have a very strong commitment to sustainability. So we're very appreciative of their support. And I want to also thank our co-host tonight, which is our additional SSLI staff and our amazing student manager, Nick Koenig. He is a senior at EKU, majoring in biological sciences, and then our two amazing student interns, Savannah Clark, who is a senior biology major, and Savannah Gosney, a junior wildlife management major at EKU. And we are also especially pleased to introduce our guest speaker tonight, which is Dr. Don Yao. And Dr. Yao is a professor in the Department of Geosciences at EKU, and he studied climate and climate change since the 1990s. He is originally from Mayport, Florida, and earned his PhD in geography at the University of South Carolina in 2003 with a focus on climatology. And his professional interests are how humans interact with the environment, which of course includes climate change. And he's appeared on a number of local news stations and also was featured on NPR talking about climate change. And so we are very excited to have him here with us tonight. And I'm about to turn it over to Dr. Yao, but before I do, I know most of us are probably pretty familiar with Zoom etiquette by now, but just to give you a rundown of logistics for how we will do things tonight. Dr. Yao is going to talk to us for about 25 to 30 minutes, and I'd ask that everybody could please mute your microphones during this time. And if you do have questions, however, you can either feel free to drop them in the Zoom chat box, or you can, jot them down and we'll have some time afterward. We very much want this to be a conversation. We want your questions, so we hope that you will ask questions. So following Dr. Yao's talk, we'll have some time for the questions and discussion. And then we want to actually have our student interns to give us a brief overview of some resources that are available for learning more about climate change and what you can do as an individual. And then we're going to close with some ending remarks from our student manager, Nick Koenig. And so with that, I am actually going to turn it over now to Dr. Yao. Dr. Yao, you should have co-host sharing screen abilities. So.
Okay, thank you, Kelly. Let me see if I can get my PowerPoint to show up for everybody. Do it. Okay, so as Kelly said, I'm Don. I'm happy that everybody's here, especially on a Friday evening. We're here to talk about climate change, which is something that's very important to many of us and to the planet as a whole right now. And somehow I knew this morning when I woke up and the pond in my yard was frozen over, I knew that I was going to be talking about climate change today, because that's the way it goes, right? You get a cold day and it's time to talk about climate change. Well, let me first talk about or go over briefly what we're going to be talking about. First of all, we're going to be talking about what is climate change. Once we've established that, we will talk about why climate change is happening, and sprinkled throughout, we'll talk about some of the common misconceptions that people have about climate change. And in the time remaining, we'll talk a little bit about how you can have productive conversations or at least hope to have productive conversations about climate science and climate change with those who are maybe a little more skeptical. Being a climate skeptic is not a problem. We should all be skeptical about science and always question where our facts are coming from. But, well, we'll save that till the end. First thing I want to do, though, to kind of get the ball rolling is get everybody to go to a website, menti.com. What it's going to do is it's going to ask you just a couple of questions, and you can respond to each of these questions with either one-word responses or short responses. And as your responses are recorded, Menti will show us in real time what your responses are up on the screen. So if Kelly, if either you or Nick would put this link, menti.com, and the code up in the chat so that I can get out of the PowerPoint for a moment and actually go to Menti so we can do this little exercise. Let me switch the screen that I'm actually sharing here and go to the Menti website. And there it is. All right, everybody should be looking at the question now up on my screen, and hopefully also once you've logged into Menti, first question is, what has changed and how do you know if something has changed? So forget about the whole climate change thing that we're talking about right now. We're just talking about plain and simple change. How do you know what changes or if changes happen? And as your responses are recorded, hopefully they'll be populating up on the screen here. All right, I'm seeing our first few responses coming in. Words such as different, something occurring. Yeah, okay. I think different is going to be a major term in terms of how we recognize change. And we see that different is indeed growing, meaning that more and more people are saying that change means something is different. It's occurring, it's modified, altered, shifted. Okay, we're also seeing words up there such as weird or odd. Change doesn't always have to be unusual or weird, but sometimes it certainly is. Yeah, we could do this activity for as long as we like, but I think it's pretty clear that the big word that we're looking at here is different. Something is different. And if we're going to say that something is different, it means that there's been something that has happened between a time past and the time that we're looking at currently. So something is different. And all of these things that you're putting up there are certainly part of change. So with all the responses that I'm seeing, I think this audience has a very good handle on what change is. Now, the next question is a little bit tougher and may require you to dig a little bit deeper in your thought resources, but here it is. Here's your next question. What's climate and what things are part of climate change? And I'm seeing the big word is weather. I'm also seeing average weather, long-term weather, weather patterns, global, averages, Earth. All right, so this one is maybe not quite as clear cut as what we saw with change, but it's definitely got something going on with the atmosphere. Is it weather or is it something different? Well, I'm seeing the word weather is still the biggest, but again, I'm also seeing average weather and weather patterns, regional, global, talking about different scales. I'm seeing some words like temperature up here that are getting at specific things that are involved with our climate, specific measures of our climate, precipitation. Yeah, okay, great. Well, that seemed to work out just fine. Let me turn that off now and go back to our PowerPoint. And let's talk about what we just came up with. We started off by talking about change, which sounds easy enough, but then we added the more complex term of climate. And if we put our answers together, climate change, well, with change, we said something's different. And if something's different, we have to compare it to at some point in the past. Climate is a little bit more complex and difficult to discuss. But climate is not just weather. Weather is what's happening here and now at a given place at a given time. Climate is more long-term average weather patterns that occur over many years or even decades or longer, perhaps, to describe what the average weather patterns are like at a given place. So if we're talking about climate change, we're talking about average patterns, average temperatures, precipitation, winds, everything that's involved with weather on average is changing over time. And that's exactly what climate change is. Now, that brings up one of our first misconceptions, though. I mentioned at the very top of our presentation here that my palm was frozen over this morning, so I knew it had to be a day to talk about climate change, and that was a joke for those who didn't catch it. But this guy, back in February of 2015, picked up some snow outside the Capitol building and brought a snowball onto the floor of the Senate to make the point that it's cold outside, so therefore global warming is a hoax. Well, Senator from Oklahoma, what I would say to you is a quote from one of my favorite authors, Mark Twain. Mark Twain said, "Climate is what we expect, weather is what we get." In February in Washington, D.C., I might expect it to be cold and a snowstorm wouldn't be out of the question. So I'm not sure what this particular senator was expecting on that day in February. But the point of the matter is weather patterns can change pretty large from one day to the next. I mean, we could have a day in the 70s followed by the next day that doesn't get above freezing. So there's a big difference between climate and weather. Climate, again, is basically long-term weather patterns. So just saying that we're having one day that's particularly cold or isn't overly hot, that doesn't mean that the climate isn't changing. We have to look at longer-term patterns to understand what climate is and how, in fact, it is or isn't changing. So what do you adults in the United States think about this whole concept of global warming and climate change overall? I'm going to share a couple of surveys with you. The first of them was put on by Yale University and George Mason University, and they interviewed U.S. adults, that is people over 18 here in the United States, and what they found from 2019 is that a large majority think global warming is in fact happening. Only 12% do not, but I think it's always important to recognize that 12% sounds small, but that's still 1 in 10 people, adults in the United States, that simply don't think that global warming or climate change is happening. Now, following up on this, the survey says, well, okay, if you think it's happening, what do scientists think? Now the numbers are pretty different. Only 55% understand that most scientists think global warming is happening. And the numbers get even worse if we dig a little bit deeper. Only 22% understand how strong the level of consensus among scientists is, and 24% thinks that there's a lot of disagreement. Almost a full quarter of US adults think that there's a lot of scientific disagreement about whether or not global warming is actually happening. Well, here's the reality. Scientists do agree on this topic. The scientific debate has long been basically over regarding whether or not climate change is happening. In fact, almost every scientific organization worldwide has endorsed this consensus position that, quote, most of the global warming in recent decades can be attributed to human actions. So not only is it happening, but humans are the primary cause of the climate changes that we are seeing. And what this graphic is showing you is a handful of studies that have been done over the years that are looking at the peer-reviewed literature to say how many scientists say climate change is happening and think that humans are largely responsible, how many have a differing opinion. And you can see that the overwhelming majority agree that humans are the main cause of the climate change that we're seeing currently. So saying that the scientists aren't on the same page, that's just a huge misconception. The scientists do in fact agree, and the few dissenters, if you will, are largely what we would consider to be non-experts in climate or scientists who have been paid off by special interest groups to purport the story that those interest groups want to tell or want to share. So building on the idea that climate is changing and keeping in the back of our minds that humans are largely responsible for the changes that we're seeing now, let's dig a little bit deeper into the causes of climate change and also try to differentiate between changes that have occurred over the history of the entire planet versus changes that have occurred over the past 100 years or so. Now, for people that say that climate change is a natural thing, they're right. There's no question that Mother Nature plays a huge role in regulating our climate and also causing changes to our climate periodically. Some of these changes that are natural could be external to the Earth atmosphere system, things such as our sun, for instance. If the sun's putting out more energy is going to reach our planet, and by and large, we should be warmer. At other times, the sun is going to be producing less energy. The orientation between the sun and the moon and the Earth change over large time scales. Milankovitch told us in the early to mid 1900s that things such as the orbit of the Earth around the sun is not constant in its shape. The tilt of the Earth on its axis changes over about 42,000 years. Even the direction that the North Pole is pointing changes over about 27,000 years. These changes in Earth's sun geometry also have a direct impact on Earth's climate, but the cycles that I were mentioning over tens of thousands of years, they're not likely to have a huge impact over a human lifetime. Something external that could, though, is an extraterrestrial impact. If a meteor comes and strikes our planet, that can have immediate and lasting impacts that could go on for several years after that initial impact. Some things inside the Earth itself, like volcanoes, for instance. Volcanoes are huge regulators of Earth's climate. Anytime there's a volcanic eruption, despite the differences in volcanic chemistry from one volcano to the next, every single one of these volcanoes is going to be emitting huge amounts of greenhouse gases, such as carbon dioxide and water vapor. And those, of course, are going to also contribute to Earth's greenhouse effect. Plate tectonics, the fact that Earth's orientation of continents and oceans changes over long periods of time, that affects the global energy balance, as does changes in ocean circulation. And natural oscillations, things like El Nino and La Nina, also affect global climate naturally. But Mother Nature isn't alone in causing these changes. Humans also are responsible for changes. Some of the things that we do are pretty obvious, things like thermal pollution. You turn on the engine of your car and heat is coming out of the exhaust and off of the engine. Well, that little bit of heat contributes to the warmth of the surrounding environment. Aerosol generation. That same engine in your car that's generating some of that thermal pollution is also going to be emitting lots of aerosols into the surrounding environment. Depending on the size and the chemical characteristics of those aerosols, they'll have varying levels of effect on Earth's climate. Bigger than both of those are changes to land surfaces. Whenever we cut down a forest, for instance, we are certainly changing local water and energy balances that can have scalable effects up to the global scale, especially the more of those things that we do. But the single biggest thing that humans are doing and have done historically to affect climate are changes to atmospheric chemistry. These changes to atmospheric chemistry can be things like aerosol generation, but the things that I'm referring to now are enhancing the Earth's natural greenhouse effect. Whenever we put excessive amounts of greenhouse gases into our atmosphere, energy gets trapped into the Earth-ocean atmospheric system. And the single largest sources of those enhanced greenhouse gases are by far the burning of fossil fuels. There are certainly others that deserve mention, but if we are going to say there's one single largest anthropogenic or human cause behind contemporary climate change, it is certainly the burning of fossil fuels. It's not even close as to what would come in second behind the biggest contributor to climate change. So what do people think about this? Well, a lot of US adults actually think that people are too small or our time on the planet is too short to really alter things. The map that you're looking at on this slide was produced by Yale University as a result of some of those surveys that I was talking about earlier. And what this particular map is showing us the percent of US adults who think that global warming is caused mostly by human activities. You can see that some parts of the country, particularly the West Coast, people are a little bit more in agreement with that statement. In our own state, Kentucky, we've seen a lot of blue here, meaning that a lot of Kentuckians simply don't think that humans are the primary driver behind climate change. By the way, I just want to mention real quick, I've got a link to this right here. If you want to go look at these maps in your own time, you can look at other questions, look at absolute values, look at differences between the values of one county and the national average. It's a terrific site. I've also down here in the notes on most of my slides, in fact, I've got links here. This one is going to take you directly to the site where this map came from. Also some other notes on here. So if you want to go back in your own time and look through this presentation, I hope that this is a resource that all of us can use. But thinking about these surveys, again, 32%, almost a full third of US adults think that climate change is mostly due to natural changes. Well, what does science say about that? If we look at the peer-reviewed literature, these studies, there's 10 of them from 2000 to 2016. And what they're all doing is they're looking at, does the study say, is climate change mostly human? Is it mostly natural? And what percentage of the change is caused by each? And you can see that all 10 of these studies, the overwhelming majority of the contribution to global warming over the past 50 to 65 years has been human. And very little, comparatively speaking, has been natural. And in fact, the majority of these studies suggest that naturally we should actually be experiencing a modest cooling, which means the warming that we are experiencing is not just starting from a baseline of zero. We're overcoming what should be a natural cooling effect, and we're warming on top of that. So again, the science is not in confusion about this. We're not in disagreement. The science is very clear that climate change is not only happening, but humans are the predominant cause. Now, another thing that I've heard quite a bit is that climate change is natural. Climate is always changing. It's always going to continue to change. And to those people, I would say you're absolutely right. Nature is a major source of climate change. Where I would begin to disagree with them, though, is that by and large, natural climate change happens relatively slow. Now, there are certain instances where things like a volcanic eruption, and some of these major eruptions are even pointed out on this graph. Volcanic eruptions can have a pretty dramatic change, but they're kind of short term overall. something like a meteorite impact that can also have a pretty rapid change. But what we're looking at in this diagram is change over the past roughly 2,000 years. Most of this data is coming from proxy measures like ice cores, and you can see that we're fairly stable. In fact, for the past 1,000 years, maybe cooling off a bit until the modern warming is discovered not long after the turn of the century. And then we see this huge spike in global temperature in recent history. There's nothing natural that can explain the spike that we're seeing right here. There hasn't been any major natural catastrophic events that are explaining this dramatic rise in temperature over the past 50 plus years. So it's definitely human. All right, next, another misconception here. Climate change isn't that big of a deal, or at least not to me. That Yale survey, once again, 45% of US adults thinks that people in the US are being harmed by global warming right now. But despite that, a full third, 33%, say that global warming is not too or not at all personally important to them. Another survey that's even more recent, this one from just this past summer, conducted by the Pew Research Center, shows that the number of US respondents who say that global climate change is a major threat to the United States has in fact increased from about 45% up to 62% since 2013. However, there's still 14% who said global climate change is not a threat to the United States. And comparing that statistic to a 14-country median from the same study, the median was only 5%. So people in the US are almost 3 times more likely to say that climate change is not a threat to our country compared to other countries in this survey. Well, the reality is climate change is very important. Some of the things that we are seeing in our atmosphere and in our oceans are warmer temperatures in the lower troposphere, warmer temperatures in our oceans. Some of the consequences of these warmer temperatures are melting ice. There's less snow coverage now than there was in the past. Lots of our glaciers and ice sheets are melting more than they're regaining ice. Some of that melting ice is contributing to rising sea level, as are the warming water temperatures themselves. Our oceans are also becoming more acidic as more of the carbon we're emitting into the atmosphere is dissolving into the ocean and creating carbonic acid. Along with these changes in climate patterns, we're also seeing more extreme events, things like floods, drought, wildfire, major storms, heat waves, etc. These are not only becoming more frequent, they're becoming more intense. That has big implications for the natural environment and for people as well. Things like this coral reef. This is in Australia, and the coral has been bleached because of warming temperatures. The bleaching occurs as the algae that has the symbiotic relationship with the corals die. And at the same time that the algae are dying, which provides the coral some energy through photosynthetic processes, this ocean acidification is literally dissolving the skeleton of the corals themselves. Habitat loss, changes in species distribution, more invasive species spread across the planet. A lot of species are in trouble, and unfortunately, a lot of species are going extinct. And we know from the geologic record that at least 5 times in the history of the world, there have been what we call mass extinction events, where huge amounts of species go extinct in a relatively short period of time. Some people fear that we may be on the verge of a 6th mass extinction event being brought on largely by global climate change. One thing that I will mention is that all of these 5 mass extinctions in geologic history, regardless of their cause and triggering mechanisms, every single one of them was associated with massive climate change, changes that were too large and too rapid for the environment to respond to. And it's not just the environment that we have to be concerned about here, it's us as well. Economic and social costs of adaptation. Changes are coming. Like it or not, even if we stopped emitting greenhouse gases today, the gases that are already there are going to cause continued change, and we're going to have to keep adapting. How do we adapt to things like storms coming into our cities, causing massive flooding? What about people like this farmer who has been farming for generations, and now the way that he's making his living is in danger because he can't grow the same crops in the same area that his family has done for generations? Lots of people are losing their livelihoods due to climate change. Food production, everybody has to eat. Globally, food production is in decline, whether it's through agriculture or even wild food sources such as the fisheries in our oceans. Clean water is becoming more and more scarce, especially in certain regions where drought is becoming more and more prevalent. Disease is spreading around the planet, partly because of more vectors like mosquitoes carrying these diseases into new areas, partly because new diseases are emerging or even new strains of existing diseases are emerging. With the taxing that we're putting on our limited natural resources, this is undoubtedly going to lead to more conflict, people arguing and fighting over those limited resources. And ultimately, some people are going to have to abandon their homes. They'll become what we call climate refugees because the place that they've called home is no longer livable. And when we hear about things like climate refugees, we may think, oh, well, that's just a third world problem. That's not happening here. That's not true. There are climate refugees right here in the United States. The first one from some of the low-lying islands in southern Louisiana, people literally having to find a new place to live. So I don't want to belabor all of this gloom and doom. Let's talk about what are some of the things that we can do. Well, there are a lot of things that we can do individually and collectively to address climate change. First off, your own personal lifestyle choices. I know that Savannah and Savannah are both going to be talking about this a little bit more later, so I don't want to belabor these points here, but simple things like what you eat, what sort of transportation you use, how much electricity you use or don't use in your home, whether or not you are using renewable energy resources. All of those things matter. Perhaps even bigger are things that you can do politically. Support candidates who share beliefs that matter to you. Lobby for legislation to be passed that supports the interests that you believe in. Going to public rallies and demonstrations, it gets the word out. Now, here's another thing that this is from that Yale survey again. Almost half of US adults think that new technologies can solve global warming without individuals having to make big changes in their lives. We could look at that a couple of different ways. One would be a pessimistic view that half people think, oh, science or technology is going to solve this anyway, so I don't need to do anything. I don't like that view as much as I like the other view that technology can play a role. I don't know that technology is going to completely solve this without other initiatives, but things like solar and wind power, the costs have been shrinking dramatically because of advances in engineering. Advances in our batteries have allowed us to store this power more usefully and more able to disseminate this power at another later date. Enhancing sinks and reducing sources of carbon. There are things that we can do even in our own gardens at home to help the soil absorb more carbon. And if we did these things on a larger scale with commercial agriculture, or perhaps even on the scale of complete ecosystems like grasslands or rainforests, we can further enhance these sinks and turn them back into ways of eliminating carbon rather than producing carbon. But by far, the biggest thing to me that all of us can do and hopefully will do to help address this climate change crisis is to educate yourself. I read new articles every day. There's new studies that come out constantly, and I'm constantly educating myself more and more, not just for my own personal interests, but also so I can tell other people. People who want to know about this stuff deserve good facts. And how do we get those facts unless we educate ourselves? So if you want to learn more about climate change, there are countless resources out there, and it's real easy to get overwhelmed and not know where to start. So I kind of narrowed it down for you. I've got just 2 places to start with some good evidence about climate change where you can learn the facts and hopefully separate some of the misinformation that you may be hearing from other sources from what the actual scientific truth is. The last thing that I'll say before we move on to another part of our presentation here, I was asked to speak a little bit about how we can have productive conversations about climate change, in particular with those who may not share perhaps some of our same ideas or beliefs about climate change. And a lot of this information comes from an article that was published just last month in Scientific American, but it's also things that I've kind of cobbled together from personal experience and other things that I've read over the years. So here's just a short list, by no means an exhaustive list, but some of the things that you can keep in mind when you are talking about climate change. First up, and perhaps most importantly, and that goes for all conversations, is to listen. If you've got a person that doesn't want to believe in the set of scientific facts that you're presenting, find out what their set of facts are. What are they thinking? Why are they thinking that? Where did they get that information from? Something I think is very important is this idea of getting into fact wars. Those types of conversations can devolve very quickly, get argumentative, and nobody really enjoys those types of conversations. Now, there are times and places where that's more important, a place like peer-reviewed literature, for instance, but just in a day-to-day conversation, I think it's wise to try to avoid getting into fact wars with people. Instead of that, highlight on what you agree on. For example, if someone says that climate scientists are corrupt, well, don't focus on that so specifically. Just say, yeah, I think all scientists should be credible and ethical. We all want science that's working for the public good and not for some hidden, perhaps corrupt agenda. Try to determine places of agreement and focus on those. What goals do you share? I think most of us want a healthy environment. We want our political leaders to be ethical and just in their decision-making processes. What sorts of things can benefit all of us? The last 2 points here, stay positive and keep trying. And the last one, don't get angry or upset. You know, I've been studying climate change for a very long time now, and I've met plenty of people who are skeptics, which is not necessarily a bad thing. I appreciate people questioning the science, but some people who want to just fold up their arms and puff up and disagree no matter what. Well, accept the fact that some people are never going to agree with you and they're never going to change your mind. Don't beat yourself up over the fact that you can't convince everyone, and don't even think that you have to. I mean, here in the United States, majority rules in our political system for the most part. So if you can just convince more than half of your fellow citizens that climate change matters and it's something that we should all address, well, then that can really push the needle in a positive direction. So those are my major thoughts, and I'll kind of turn it back over to Kelly and Nick now. I think they want to have a question and answer. I'm very happy to take any questions, comments, etc. that anybody has. This is stuff that I could have talked about for days and days rather than just the limited time we had here. So by all means, questions, comments, bring them forward.
Thank you so much, Dr. Yao. That was really great. Yeah, I wanted to open it up and have anybody wants to ask any questions. I think in particular, it might be interesting if people have questions about, since we're kind of been focusing on having conversations and potential, misconceptions about climate change. What do people generally experience? What do you guys think about? What do you struggle with when people come to you and say, oh, climate change, I don't know if I believe it, or what are some of the misconceptions that we have or that we hear, or that maybe you have? This is the thing you have to do with students, where you stare at them until someone says something. What is that thing called?
Yeah.
Yeah.
Maybe let's reframe the
Say
question a
something.
bit like this.
Because I know.
With Christmas coming up, this year is a little different with COVID, but I know some of us are going to be seeing family. And if families are like mine, not everybody in your family is going to be a person who accepts climate change, and certainly not everybody's going to want to do anything about it. So what sort of questions are you expecting from your own friends and family this holiday season if climate change comes up?
I have usually a lot of people that I talk to, they acknowledge like humans are doing it. Oh, it sucks, but it's gonna hurt the economy to do anything about it, is what I usually hear.
Yeah, that's a good one, Devin. I'm glad that you brought it up. That's actually something I had in the presentation, and I took it out for interest of time. That's a very common thing that you hear. Oh, it's going to hurt the economy. Now, I can cite a number of scientific studies to back up my point on this, but doing nothing will cost us a heck of a lot more than addressing climate change. And beyond that, not everything about climate change necessarily has to be an economic negative. There are certainly things that we can take advantage of, such as alternative energy sources. Right now we're in a very fossil fuel based economy, but there's nothing saying that we couldn't switch to a more renewable energy based economy, solar, wind, et cetera, and have lots of jobs building wind farms, building solar panels, maintaining these things, updating our energy grid so that it's more efficient. When people say it's bad for the economy, personally, I don't believe it, but you don't just have to take my word for it. Without trying to go overboard in terms of citing other studies, I'll just tell you about one that was over 20 years ago. There were about I want to say 5 or 6 national labs around the United States, including Oak Ridge, who did an economic study on climate change. And they said, what are the costs of addressing climate change versus what are the costs if we don't do anything? And it was overwhelming that addressing climate change is in the long run far better for our economy than just hoping that this problem will go away.
Yeah, I agree. I think the issue with that for a lot of people is the discrepancy between short-term pitfalls and long-term gains.
Yeah, well, again, you're going to have to power yourself up with knowledge to be able to have a sound argument with these people. But in my own family, for instance, I'm from a fishing background, and the fishing is not as good as it was in the past, and my family's kind of scraping around wondering what they're going to do next. Well, climate change could offer the opportunity to switch into new jobs that we hadn't really thought of in the past. It's going to be opening up new jobs and new opportunities for people. We just have to be willing to accept it.
Yeah, it's kind of like here in Kentucky with the coal jobs kind of going away, and not because, all the politicians are the war on coal. It's because it's being outcompeted, and those people should be able to transfer to more renewable jobs instead of just being, out of luck.
Sure, and I think part of this, it's going to require a lot of government support, some government funding to, say, provide free training for people if you're coming from a coal community and you want to get into the solar power business. Well, I personally don't know anything about building solar panels, and I don't know that any of us here on the panel do, but we could all certainly learn. And if the government were to sort of incentivize these people, provide free training for them, well, then that could offer up more lucrative careers for them and probably safer as well. I know I'd rather be in a factory making solar panels than underground in a coal mine.
Yeah.
Does anyone else have any questions? Thank you for those questions, Devin.
No problem.
Yeah, I have one I can ask about, and not to get political first, but it's easier for an administration to fall into that social trap of I'm going to support existing jobs and deregulate all these environmental regulations so that the economy booms short term during my time, than it is to invest in what we know is important for the long term, like Devin was saying. But Don, I have a question about, would you have good sources if someone asks about, or you want to make the claim that weather events are becoming more extreme, and the patterns in that, like hurricanes and like weather swings, like having really warm days surrounded by really cold days?
Yeah, there's tons of research that are done on climate extremes, and it's getting more and more robust all the time. For many years, climate scientists were very reluctant to say a given event is due to climate change, for instance. Hurricane Harvey just a few years ago, some people were wanting to jump out and say, oh, this hurricane's caused by climate change. And other people were saying, well, not so fast. Well, where the science sits on that is that these events, for the most part, are going to happen anyway, but how extreme they are is largely due to climate change. So with Harvey, for instance, the rainfall that happened in places like Houston was estimated to be about 30 to 35% higher because of warmer sea surface temperatures and warmer atmospheric temperatures than they would have been had Hurricane Harvey happened, say, 20 years ago. So that's kind of where we're going now. How much is climate change exacerbating these extremes that we're seeing? But also, yeah, things are by and large becoming more common overall, things like drought and heat waves in particular. So yeah, there's plenty of literature out there, and it matters what particular aspect you're interested in. So with some things like hurricanes, it's pretty clear they're becoming stronger. There's more energy in the ocean. We can quantify that. Things like tornadoes, it's not as clear cut. Are we seeing more? Probably not. Are we seeing more stronger tornadoes? Maybe not. It's not as cut and dry as some of the other factors that we can look at.
Great. Thank you so much, Dr. Yao. With that, I see there's a question in the chat, but if the Savannahs, if you could go ahead and start your portion, that'd be awesome. And at the end of that, if you want to answer the questions in the chat, that'd be great.
Okay, yeah. Savannah, do you want to go ahead and share our screen so we can get our presentation up and going?
Yes.
So we're going to be talking about what you can do, first of all, to mitigate your impacts that can contribute to climate change. So Savannah's going to start us off with our first one.
All right. So one of the biggest things is just to limit your consumption. So i.e., don't buy things that are unnecessary or things that you're like, oh, this is really cool, and then you put it somewhere and then you just throw it away later. There's no point. So and there's other stuff like, you know, your refrigerator stops working, you throw it away. Instead, you could just take it to get repaired or give it to a friend, you know, maybe they could use one, stuff like that. So just try to find ways to repair or reuse things. There's like a lot of things you can give them a second life, you know. And another thing, try to shop more at like secondhand stores. You don't have to buy things new all the time. You know, society thinks that, you know, something quits working, throw it away. You don't have to do that. And another thing, just like single-use stuff, like eating out all the time, going to fast food restaurants, straws, utensils, a lot of that stuff is kind of, you know, you don't have to do that, but it happens. And Dr. Yao mentioned this. Sorry. Animal agriculture is a huge contributor to global greenhouse gas emissions. So livestock farming produces 65% of nitrous oxide and ammonia released into the environment. And ammonia contributes to acid rain. Nitrous oxide is 300 times more of the potential to cause warming than CO2 does. So when people think, oh, you know, transportation, you know, leaving your car running is the cause, which, yeah, that is a contributor, but, you know, so is farming. And I'm not saying, you know, be vegan, be vegetarian, you know, that's crazy and you shouldn't just like change your lifestyle that fast. Just if you want to, ease into it, but you can always just try to do a meatless Monday, something every now and then. Or if you really like cheese, like obviously eat cheese, you know. The main thing is just like cutting out red meat, because that's one of the big things.
Yeah. Savannah, if I could cut in for just a second, I like that you put what we eat really matters on here as well. Thinking about where the food that you eat comes from. You could eat corn grown here in Kentucky rather than eating corn that's grown across the continent somewhere else. But what I really wanted to say is I read an article just a couple of days ago about farm-raised shrimp. And I think a lot of us think, oh, seafood, well, that's a better choice, right? And in many cases it is. But the point that the article was making is that a lot of the farm-raised shrimp coming from places like India and Thailand, what they're doing is they are taking their mangroves, their natural mangroves, and they're turning those into aquaculture production facilities for the shrimp. So the mangroves are a carbon sink. They're turning them into a carbon source. And the big point that the article made was that we think, oh, shrimp, that's better off than eating beef. But they said that in the cases of these shrimp farms that are being built on the mangroves, that they're actually 4 times worse than beef in terms of climate change.
Yeah.
Eat farm shrimp, eat wild shrimp that my family catches.
Yep, definitely. And then like, and that's crazy because beef, like, I think one hamburger, or it might be like a quarter-pound hamburger, but is equal to a month's worth of showers. So instead of, you know, I'll just take a shorter shower to save the earth, try to eat a little less beef if possible. All right, now Savannah's gonna talk.
So another thing you can do is use your energy efficiently, which this can mean a lot of different things. So one of the things you can do is make your home more efficient, which we're going to do a workshop on next month. So I hope to see more of you guys there. We're going to talk about how much energy your appliances use, different light bulbs efficiencies, and we're also going to do a couple activities going around the science building. Given that COVID allows us to meet in person, exploring the energy outputs from different outlets in the building. But also, in addition to making your home more efficient, you can try to source your energy from efficient providers. So I know one here in Kentucky, I think, is it Columbia, that has a big solar farm in Winchester, and they a lot of their energy comes from solar energy. And so that's one thing you can do. And another very, very important one to me is starting a discussion. Dr. Yao talked about this at the end of his. Getting the word out there is so, so important to making sure that this issue is addressed. Because without people's support, action's never going to be taken by our governments. And sometimes these conversations can be really hard. I understand that. I'm like Dr. Yao. I come from, family that's more skeptical of it. And I try to have conversations with them as often as I can, but sometimes I just have to step away. But it doesn't stop me. I still go out and actively try to teach everyone that I can about, climate change and how it's going to affect us. And then, going on to the discussion is you need sources to bring information to people. So where can you get reliable information about climate change from? And I'm going to first hand the first two over to Savannah.
All right. Oh, and another thing about starting a discussion, if you are on campus, there's clubs on campus like Green Crew that you can join where we try to do stuff on campus that we can, you know. And so one of the big organizations is the National Oceanic and Atmospheric Administration, NOAA. So they are an American scientific agency that studies the conditions of the atmosphere and the hydrosphere. And they are 50 years old, but they actually the organizations that formed this group date back to 1807. And so they just monitor the atmosphere and stuff like that. So, and then NASA, you guys have probably heard of them. So the National Aeronautics and Space Administration, they are another American scientific organization. They use satellites to monitor the Earth's atmosphere, and they've been working with NOAA and the U.S. Geological Survey since the 60s. And another cool thing about them, they released the Nimbus series of weather satellites and the Landsat land resource satellites. That was back in 1964 and 1972. And they were the first Earth monitoring satellites to be sent to space.
So our next source is another one that Dr. Yao mentioned, is the Intergovernmental Panel on Climate Change, the IPCC. This is a council formed by the United Nations and the World Meteorological Program. It's got 195 members, and each year it reviews thousands of scientific papers from around the world to produce a comprehensive summary of climatic data, and also to address topics that need more research. And then another great resource is Nature Climate Change, which is a monthly journal published by Nature Research that produces the most recent and significant studies on climate change. And this is a kind of a subjournal within the Nature, which I'm sure a lot of you, if you've done any kind of scientific research, are familiar with. They have been publishing journals since 1869 and is one of the most cited journals in the world. And personally, it's one of my favorite journals, and I love to go read their editorial columns and their news articles they put up there. And Nature Climate Change doesn't just produce research or publish research surrounding the natural sciences. It also publishes research around the social sciences, you know, talking about how climate change can impact human health, and how climate change can disproportionately affect certain populations. But that is all we have for right now as our part of the presentation. If you have any questions for us or Dr. Yao, we'd love to address them right now. And thank you guys for coming.
Thank you, Savannah. I want to say one quick thing about the IPCC. IPCC is not just climate scientists. There's actually 3 working groups. Group 1 is the science that are talking about things like what causes climate change, what are the impacts. But there's 2 other groups that aren't just atmospheric scientists. The second group, they're looking at vulnerability to climate change and how different people around the world can build their resiliency to climate change. So there's a lot of social science in that one. And group 3 is largely about mitigation. What can we do? What steps can we take to limit or at least reduce potentially negative impacts of climate change? So the IPCC is totally awesome. It's not just atmospheric scientists, it's all sorts of academic professionals in all sorts of disciplines.
That's great. Thank you. So again, I know for those of you, I was letting you know that Savannah and Savannah are awesome interns. And so, and they mentioned our next workshop will be talking a little bit about energy efficiency and conscientiousness as well. So, and I think with that, Nick, you're going to close us out here.
Yeah, if the Savannahs want to address the question in the chat from Lorelei Watson, says, when do you think the largest contributors to climate change will finally be motivated to go through to go fully through with switching to renewable sources of energy? I think that's a really great question.
I think that I think that Biden has a really good plan, so hopefully something will be done sooner. But I don't think there's any way to really know.
That is definitely a big question to tackle, but I do think we're on the right path now. But I do think that there's going to still be a lot of resistance in the future. And that's why, we're hosting this workshop, is because we still need to inform as many people as possible about this to get as much public support as we can. So the more public support we have, obviously it means the more governmental support we're going to have here, at least here in the US. And that's going to help us get action done.
Great, thank you all. So just to end it off, I want to thank everyone for coming. I know this is maybe not the most convenient time. However, I've seen through the night we had like 17 or 18 max, which is really awesome. We were not expecting that many. So good job to the interns for really getting the word out there, and for everybody who helped share the word for it. I have a post survey for everyone just to get an evaluation. It is anonymous, so feel free to be as honest as possible. If you hated this, tell us. We'd love to get the feedback. If you loved it, tell us. We'd love to have that feedback as well. So there's the form in the chat. You can just click it, and if it doesn't work for anybody, just let me know. And if you have any further feedback you'd like to provide, you can always email myself, Dr. Watson, or Natural Areas. And then to plug in our social media accounts, we do have a Facebook. That is it is this link that I'm sharing right now. There we are. That is SSLI EKU. So you can follow us for future announcements of our workshops in January that Savannah Clark mentioned briefly. And lastly, I hope that everyone just stays informed and reads articles and make sure to always question the science, because I think that's a very healthy thing to do. So hope everyone enjoyed, and make sure to keep questioning.
Yep. Thank you, everybody. And yeah, we look forward hopefully to see you again next month or in January when we come back for our next workshop. And thank you so much, Dr. Yao. It was really awesome and informative. And I hope you all enjoyed yourselves. And
Thank you. It's been fun.
Thank you, guys. It was great. I love doing it.
This was fun. Thanks.
Bye. Happy holidays, everybody.
Happy holidays to you guys.
Happy holidays.